So in today's video, I'm going to be providing a very quick proof on why it is that sine squared theta plus cosine squared theta is equal to 1. This is often a very common trigonometric identity that a lot of people don't know where it comes from, but it's something that it's expected to be memorized. So here's a quick proof on that using the unit circle. Now, very frequently we define the sine to be the opposite of a triangle divided by its hypotenuse. So the sine of theta is going to be equal to opposite divided by the hypotenuse. Here we've got a unit circle right over here of radius r, and we've got a triangle over here with length x and height y. So in terms of this triangle that we've got, which is part of the unit circle, opposite divided by hypotenuse can also be viewed as y divided by r. So the sine is actually the height of the function divided by the radius. Now we can do the same thing with the cosine. The cosine of theta is generally defined as the adjacent portion of the triangle divided by the hypotenuse. And according to this triangle, the cosine is going to be x divided by r. And now what I'd like to do is make a very quick substitution using the Pythagorean theorem, because essentially what r is it's going to be the hypotenuse of this triangle. So if we wanted to figure out what r was in terms of x and y, we can go ahead and solve for that using the theorem. So essentially what we can do is add up the square of both sides and then take the square root, where it is that x squared plus y squared is equal to r squared. This is just an application of the Pythagorean theorem. This squared plus this squared is equal to this squared. So if we wanted to isolate for r in terms of x and y, we can view r as the square root of x squared plus y squared. So we can go ahead and make that substitution for this portion over here and for this over here. So this r can be substituted for the square root of x squared plus y squared. And once again here, the square root of x squared plus y squared. Now if we went ahead and squared both of these and added them up, you would notice very quickly that we would get 1. So if we were to take let's go and put the cosine first. Doesn't really matter which order you do it in. Here you've got x divided by the square root of x squared plus y squared squared. And then you've got plus y over the square root of x squared plus y squared squared. And if you went ahead and squared both of these, essentially what you would get is x squared divided by x squared plus y squared plus y squared over x squared plus y squared. Join these over a common denominator. You've got x squared plus y squared divided by x squared plus y squared. Both of these are going to cancel each other out, and all you're going to be left with is 1. And that is why the sine, when you square it and then you add it to the cosine squared, sine squared plus cosine squared is equal to 1. And there's the proof behind it.